The physical and chemical properties of a piece of matter can be used to distinguish it from another piece of matter. So, what is a physical property of matter? A physical property of matter is a property that the matter displays without changing its composition. Nothing fundamentally will be changing about the substance. For example, if you flatten a penny, you have changed it from something to something else, but fundamentally, you have not really changed anything about a penny. Chemical properties of matter, on the other hand, is a property of a substance that would change the fundamental nature of the substance. For example, if you burn a piece of paper, what you get from burning the piece of paper is not the same thing as the piece of paper you burned. This is another example of physical property: boiling. Boiling is simply a process where a liquid is physically changed into a gas, but that liquid and the gas are still the same compound. For example, if you boil water, you change the liquid water into the gaseous water that we call steam, but steam is still just a different form of water. So the fundamental nature of the water is still intact. However, rusting is a chemical property, because when iron rusts, for example, it will chemically combine with oxygen to become rusts, which is a completely new compound. So the pure iron atoms would now have oxygen atoms inside them, which means as human beings we cannot easily separate the iron from the oxygen. Let us quickly take a look at some questions on physical and chemical properties. Hydrogen gas is explosive. Should we consider that physical or chemical properties of hydrogen? Explosion. Well, explosion is a chemical property, because when hydrogen explodes, it becomes something completely different. Silver has a shiny appearance. Shiny here is a physical property, because you may have some dusts on the silver and it will lose its shiny appearance, but you can simply blow off the dust and you get back your shiny silver. Dry ice sublimes. Now, what does it mean when you say something undergoes sublimation? It means the substance goes from the solid state directly to the gas state without first forming a liquid. So, is that a physical or a chemical property? It is a physical property, because if you capture the vapor and you compress the vapor, you would get back your solid dry ice. Copper turns green when exposed to air. Well, a very simple rule of thumb: anytime you see a color change, that means a chemical reaction has occurred. So, if copper turns green when exposed to air, that means this is a chemical reaction. So we will consider this chemical. What about physical and chemical changes? Physical and chemical changes are usually what will occur to a substance when their physical properties or their chemical properties changed. And just like the definitions of physical properties that we learned about earlier, a physical change is simply a change in appearance, not in the fundamental composition of the substance. For example, boiling, like we looked at earlier. When a substance boils, it simply goes from liquid to gas, but the fundamental nature is still the same. On the other hand, chemical change would involve the matter completely changing to something else. For example, remember when we burn a piece of paper. So, burning is a chemical change. We are going to learn a lot more about chemical changes in this course. This is a very simple demonstration of chemical changes. If you buy a lighter, the liquid butane in the lighter, if you release the liquid butane, it is a very volatile liquid. It will immediately change into gas. But if you do not ignite the gas, all you have done is made the liquid vaporize into a gas, which means the gas you have is also butane, the same substance, just a different appearance. However, if while you are releasing the butane, you ignite so that the gaseous butane begins to burn, the burning process will generate carbon dioxide and water molecules, which is a completely different situation than what you started with. You started with liquid butane, you ended with carbon dioxide and water. So, you have completely changed the fundamental nature of the original substance. Let us take a look at some questions on physical and chemical changes. Categorize the following as either physical or chemical change. Copper metal forming a blue solution when dropped in concentrated nitric acid. Again, this is suggestive of a color change. And remember the gist I gave you earlier? If there is a color change, you have a chemical reaction. So this is a chemical change. A train flattening a penny. I already mentioned this earlier, and that is a physical change because you have not really changed anything about a penny. A match igniting a firework. Ignition simply means you are burning something, combusting it, and that is a chemical change. Ice melting into liquid water. Melting is a physical change because all you are doing is changing the solid into a liquid, only in appearance. You can freeze back the liquid to get back your ice. So it's a physical change. A very simple hint on determining whether a change is physical or chemical is to look at reversibility. If the process can easily be reversible, then it is physical. So, physical changes are easily reversible. On the other hand, chemical changes cannot be easily reversed. For example, rusting. There is no easy way you can change a rust back to iron. Now we are talking about changes in the properties of matter. It can be a physical change or a chemical change. But at the end of it all, we have not destroyed or created a new piece of matter from the physical or chemical change. And this is what is known as the law of conservation of mass, which simply states that in ordinary chemical reaction, matter is neither created nor destroyed. Let me explain what that law of conservation of mass means. It means this total amount of matter that you begin a reaction with will exactly be the total number of matter you end the reaction with. For example, in the butane ignition, the lighter fluid that I explained earlier, when you ignite butane, what you are doing is essentially mixing oxygen with the butane, and in the presence of a spark, it will burn to give you carbon dioxide and water. If you, for example, begin this reaction with 58 grams of butane and you mix in 208 grams of oxygen with it to give you a total of 266 grams. Well, if you capture all the carbon dioxide produced from the reaction and you capture all the water produced and you add the masses of the two together, you will also exactly get 266 grams. Because although you have performed a chemical reaction, your pieces of matter have changed, but you have not really created nor destroyed matter. You have only transitioned it from one form to another.